Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, we're going to take what we've learned about how and why climates change and apply it to the changes underway today. And what we'll find is a human fingerprint. So far in this series, we've seen compelling evidence that the planet is warming. If you'll recall, we arrive at this conclusion by compiling many independent lines of evidence, all consistent with a warming planet, none inconsistent. And we can make a similar case for attributing this warming to human activities, principally the burning of fossil fuels. So let's take a look. First, given what we've learned about energy flow and the distinction between regional changes and planetary changes, it's clear that the issue we're facing is an energy imbalance. Well, that's because the temperature of the entire planet is rising. Of course, that could be happening naturally, so what makes us think this energy imbalance is from burning fossil fuels? As was the case for warming, the case for attribution of this warming to humans is built from a collection of independent lines of evidence. One of the biggies is that we measure elevated levels of carbon dioxide in the atmosphere, well, as we've seen. What's more, the additional CO2 in the atmosphere carries with it a fossil fuel signature. Now, this part is a little complicated, but it has to do with something called carbon isotopes. Think of these as different flavors of carbon. Carbon that has been sequestered away from the atmosphere, deep underground for millions of years, like coal, oil, and natural gas, has a different flavor than carbon that is part of the carbon cycle. That's been continuously moving from the atmosphere to plants to humans and the soil and back to the atmosphere. As a result, we can tell the extra carbon in today's atmosphere is coming from fossil fuels because it has that fossil fuel carbon flavor. Well, this is no surprise, of course, because burning fossil fuels releases the carbon they contain into the atmosphere. So these measurements confirm what we suspect should be true. Burning fossil fuels raises carbon dioxide levels in the atmosphere. Well, next, we know that carbon dioxide absorbs infrared light in the atmosphere. Well, that means our satellites should see changes in how much infrared light is leaving the planet. And they do, consistent with what we expect. Finally, as we noted in a previous video, we know that the planet's energy imbalance isn't from more sunlight because we measure the incoming solar energy and find it's not changing. Well, actually it's going down a little bit, but close enough. So all of these independent measurements then are consistent with each other. There's more carbon and it's from burning fossil fuels. Well, next up are responses in the Earth system. In addition to the rising global temperatures, which we already know about, there are a couple of responses in particular we should mention. First up is an increasing acidity of the world's oceans, specifically the ocean surface waters. Now, this is something of a companion effect to the warming atmosphere, and it's happening because not all of the extra CO2 we're dumping into the atmosphere stays in the atmosphere. Some of it dissolves into the oceans instead, and that causes the formation of carbonic acid. And we actually observe this happening, giving even more confidence in the direct measurements of increasing CO2 in the atmosphere. Another pretty interesting phenomena is that when greenhouse gases warm the lower atmosphere, the physics tells us that the upper atmosphere, the stratosphere, should actually cool as a result. And this is pretty easy to understand. Adding greenhouse gases to the lower atmosphere traps energy down low, preventing it from passing through the upper stratosphere, where some of it would have been absorbed. But since that energy is now trapped, it never makes it to the upper atmosphere, and that layer cools instead. And our instruments have actually observed this predicted response of the Earth system, and those observations are in agreement with the amount of cooling the physics say we should see based on the amount of fossil fuels we burned. So the Earth is responding as we would expect to be consistent with our measurements of elevated carbon dioxide. Another important piece of the human attribution puzzle is what I like to call the "can you hear me now" effect. And that is simply this. The physical theory that tells us a molecule of carbon dioxide should absorb certain wavelengths of light and then convert that light energy into thermal energy in the atmosphere, heat, is the exact same physical theory that allows us to build things like computers and cell phones, LED lights, digital cameras that take pictures of digital thermometers that read 118 degrees Fahrenheit. In fact, it's the exact same physics equation, the Schrödinger equation, that underlies all of it. So if you've ever held a smartphone to your ear and said, "Can you hear me now?" and gotten a response, then you should be taking human-caused climate change pretty seriously, because it's the exact same physics. Which brings us to one final point. Since we know that the burning of fossil fuels produces carbon dioxide, and we know that carbon dioxide is a greenhouse gas, and we know that greenhouse gases trap energy and warm the planet, and we know that the planet is indeed warming, well then, if, let's say for the sake of argument, we wanted to postulate that it is not the burning of fossil fuels that's warming the planet, then we would have to come up with a reason as to why not. Not only would we need to figure out what is warming the planet, we'd have to figure out why something that should be warming the planet isn't. You see my point. It's like walking out into your yard after a big windstorm and finding a maple tree lying on its side. You could take the position that it wasn't the wind that knocked it over, but then you'd have to explain why not, and what did. So, there we have it. A big fat human fingerprint on Earth's rising temperatures. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.